Another case of a non-homogeneous differential equation, which we might need to solve, has on the right-hand side a product of a polynomial and an exponential function and a trig function. And the way to guess a particular solution for these is pretty much to combine what we've done for each of the cases individually. So to guess a particular solution for a non-homogeneous differential equation of the form nth derivative of y plus something n minus first derivative of y, etc. Let's say we have c x to the k e to the ax cosine of bx, or c x to the k e to the ax sine of bx, or a sum of those on the right hand side. Now in the exponent here we have an a inside the trig function b, so that usually corresponds to a plus bi being a root of the auxiliary equation or not. So let's say with a plus bi, which will also appear with a minus bi, roots of the auxiliary equation of multiplicities m, we're going to guess yp equals x to the m e to the ax a naught plus a1x plus up to ak x to the k cosine bx plus x to the m e to the ax b naught plus b1x, etc. up to bk x to the k sine of little bx. Where multiplicity m equals 0 means a plus and minus bi are not roots of the auxiliary equation. So for example, let's look at the non-homogeneous equation y double prime minus 3y prime minus 4y. So the same left-hand side that we've done in a couple examples. But on the right-hand side, let's have 3x e to the negative x sine of 2x. Now the homogeneous differential equation, y double prime minus 3y prime minus 4y equals 0, has a solution space with basis e to the 4x and e to the negative x. Now, even though we've seen e to the negative x here, the fact that it's next to sine means that we're really looking for 1 plus or minus 2i as roots of the auxiliary equation. I'll write the auxiliary equation down too. So basis this and auxiliary equation r squared minus 3r minus 4 equals 0, which factors as r minus 4 r plus 1. Now 1 plus or minus 2i is not a root. There's not two roots. 1 plus or minus 2i are not roots. So m equals 0 in this case. There's nothing here appearing with multiplicity, anything in the auxiliary equation. So we guess that yp equals, since we've got a polynomial of degree 1, we'll say I'll put the exponential first, e to the negative x a naught plus a1x, and then cosine 2x plus e to the negative x b naught plus b1x sine of 2x. Now, I don't want to actually solve this one because I've got a lot of constants and we would need to use triple product rule for the first derivative and then lots of product rule for the second derivative too. I just wanted to show you how to form the particular solution. Another example, I want to use a different left-hand side and the same right-hand side. So y double prime plus 2y prime plus 5y equals 3x e to the negative x sine 2x. We have this non-homogeneous differential equation, y double prime plus 2y prime plus 5y equals 0 is the homogeneous differential equation. The auxiliary equation is r squared plus 2r plus 5 equals 0, which doesn't factor so easily, but we can use the quadratic formula. So r is going to be one of the numbers negative b plus or minus square root of b squared minus 4ac all over 2a. So we have negative 1 plus or minus square root of negative 16 is 4i over 2. In other words, negative 1 plus or minus 2i. Now on our right-hand side, the real part is in the exponent, negative 1, and the imaginary part is in the trig function, 2. So we do have a 1 plus or minus 2i here, corresponding to a root of the auxiliary equation. Each of these comes up with multiplicity 1. So we'll guess, first of all, x to compensate for this already being a root of the auxiliary equation, e to the negative x, and then we have a 3x here, so we need a naught plus a1x, and then cosine 2x, plus x again, e to the negative x. This first x is for the multiplicity of this root appearing in the auxiliary equation. B naught plus b1x for the 3x here, and then sine of 2x. Again, I won't actually solve this because it's going to take so many product rules that, I don't know, too much work. But I want you to see how to form the guess for the particular solution. The end.